Transportation is about movement. It connects us, it fuels our economies. But it also comes at a cost. A significant portion of this cost is the weight of the things we move. From the trucks rumbling across continents to the ships navigating vast oceans, every kilogram adds up. This is a challenge with a cosmic scale. Think about the fuel needed to power these massive vehicles. Think about the wear and tear on roads and infrastructure. Now imagine if we could lighten this load. Imagine the potential for efficiency, for sustainability, for a brighter future. This is the promise of lightweight materials in transportation. This is a journey worth taking. For centuries, we've relied on heavy metals like iron and steel. They built our trains, our cars, our ships. They are strong, durable, and reliable, but they are also heavy. This weight comes with a price tag. It means burning more fuel. It means higher emissions. It means a heavier footprint on our planet. Lead, another heavy metal, has long been used in batteries, but its weight and environmental impact are significant drawbacks. The future demands a shift. We need materials that are strong and reliable but also light and sustainable. We need to break free from the burden of tradition. Imagine materials strong as steel but significantly lighter. This isn't science fiction. This is the reality of materials like aluminum and carbon fiber. Aluminium, for example, is about 1/3 the weight of steel. This translates into immediate benefits. Vehicles made with aluminium are lighter. They use less fuel. They produce fewer emissions. Carbon fiber takes this even further. It's even lighter than aluminium and incredibly strong. It's already revolutionizing aerospace and automotive industries. These materials are not just lighter, they're often stronger and more durable. They represent a new era in transportation. The aerospace industry understands the importance of weight. Every gram counts when you're trying to defy gravity. That's why they were among the first to embrace lightweight materials. From the earliest aircraft made with wood and canvas, the quest for lightness has been relentless. Today's aircraft use advanced materials like carbon fiber composites. These materials are incredibly strong and lightweight. This allows planes to be more fuel efficient and fly farther. The future of air travel will be even lighter, faster, and more efficient, and it will be driven by the continuous innovation in lightweight materials. Section 5. Smooth sailing lighter ships for a brighter future. The world's oceans are a highway for global trade. Massive ships transport goods across continents. But these ships are heavy. They require enormous amounts of fuel. This is where glass-reinforced plastic, or GRP, and fiber-reinforced plastic, or FRP, come in. These materials are strong, durable, and resistant to corrosion. GRP and FRP are already used extensively in shipbuilding. They are used for everything from small boats to massive cargo ships. These materials offer significant advantages. They are lighter than traditional steel. This means less fuel consumption and lower emissions. The future of shipping is lighter and more sustainable, and it's being built with materials like GRP and FRP. Section 6. The heat is on, the challenge of fire resistance. There's a challenge in the quest for lightness. Some lightweight materials are not as fire-resistant as their heavier counterparts. This is a critical concern, particularly in transportation. Safety is paramount, but scientists are rising to the challenge. They're developing new fire-retardant coatings and treatments. These innovations are making lightweight materials safer for use in cars, planes, and ships. The goal is clear: combine lightness with fire resistance without compromising either. Section 7. A new dawn of materials, innovation in the Crucible. We are on the cusp of a new era in materials science. Nanotechnology is revolutionizing how we design and create materials. We can now engineer materials at the atomic level. This unlocks incredible possibilities. Imagine materials that are both feather-light and incredibly strong. Imagine materials that can self-heal or adapt to different environments. These are not just dreams. These are the potential realities of nanotechnology in material science. The future of transportation is being forged in labs and research centers around the world. Section 8. Beyond the horizon, a glimpse into the future of lightness. The future of transportation is bright. Lightweight materials will play a pivotal role. Imagine cars that are lighter and more fuel efficient. Imagine aircraft that can fly further and carry more passengers. Imagine ships that glide through the water, leaving a minimal environmental footprint. This is the future we can create, a future where transportation is efficient, sustainable, and accessible to all. Section 9. Our lighter, brighter future. A universe of possibilities. The universe is vast, it's full of mysteries and wonders, but it's governed by laws, the laws of physics, and one of these laws is gravity. Gravity pulls us down, it makes things heavy, but we are not bound by these limitations. We have the power of ingenuity, we have the power of innovation, we have the power to create materials that defy expectations. Lightweight materials are not just about saving fuel or reducing emissions, they are about pushing the boundaries of what's possible. They are about creating a lighter, brighter future for all. A future where the only weight we carry is the weight of our imaginations.